Good morning and good day. Good morning and good day to all audience and viewer from Masa University Facebook page and YouTube channel. Welcome to the webinar conducted by Faculty of Engineering, Built Environment and Information Technology of Masa University. My name is Umi Nadia binti Nur Ali, a lecturer from Faculty Engineering, and I will be serving as your moderator today. Today we will be hearing a presentation from Dr. Muhammad Nordin bin Muhammad Nurani. Dr. Nordin is a PhD graduate from University Technical Malaysia Melaka, majoring in mechanical engineering. His specialty in tripology 3D printer polymer, which he has been engaged with since his degrees years up to now. His research mostly cover wear and tear of 3D plastic polymer, such as plastic bearing. Currently, he is a lecturer at Masa University that teach mechanical design process as well as research in 3D printing. He has article publication in ISI and Scopus Index for both corresponding and co-author. Without a further delay, I would like to welcome Dr. Nordin, who will be speaking to us with topic endemic business. Okay, Dr. Nordin, the floor is yours.
Okay, good morning and hello to everybody. Okay, my name is Muhammad Nordin. So today I will conducting a lecture on how is 3D printing works and impact of towards application. So I will show the slides. Wait, share screen. Slides. Can you see? Can you all see? No?
Yes, Doctor. We can see.
Can you see the slide? Okay.
Yeah.
Okay. So first thing first. Okay, what is 3D printing about? And the other name is additive manufacturing. Okay. So a brief introduction on 3D printing. So 3D printing is a form of additive technology that where three-dimensional object is created by laying down successive layer of material. So the other name for 3D printing is known as additive manufacturing. So basically, the 3D printing using uh, the process is to melt the filament and melt the filament on top of the layer and on top of the layer to form a different shape. Okay, so this is some of the story of the 3D printing. So I will just brief introduce to you. Okay, so the first the important thing is that the FDM is or the other name is fused deposition modeling or SLS, selective laser sintering, was introduced into uh, MIT, which is Massachusetts Institute of Technology. So the before 3D printing, the other name, the first name is 3D dimensional printing technique. So during that time, uh, this institution focusing on building, improve the 3D printing. So the terminology, the important terminology in additive manufacturing is that the first is additive manufacturing by creating object through sequential layer by layer. And other one is rapid prototyping using fabricate a scale of a part or assembly using three-dimensional computer-aided design. So CAD data is software like AutoCAD 3D, which mean not AutoCAD. AutoCAD they are 2D and 3D. So AutoCAD also can. Then other is CATIA also can. And the other terminology is subtractive process, which is removal of material by cutting or drilling. Stereography is defined as Charles W. Pohl. So the system of generating three-dimensional object by creating cross-sectional pattern or object to be formed. Okay, so we can see on this two figure the uh, okay sorry. So okay, this one, the traditional conventional method. So basically, we have a raw material. square, we remove the other parts, so then become a shape. And now, right now, the
Sorry,
plan,
Dr. Noden, disturb you. I want to tell you that your slide is not moved.
yeah,
Your slide is not moved. Can you
oh,
uh-uh.
yeah, should I not move? Uh,
You can try
share
upload again.
session. Mm, this one, okay. Can you see?
Yes, I can see. Can you
Okay,
yes,
I
okay,
move.
okay. Yeah.
Okay, is it okay? Okay, I
Yeah, okay,
continue.
okay now. Yeah.
Okay, okay. So I this one okay. Okay,
Yes, Dr. Noden. Okay, you can proceed now.
okay. So sorry for the issue. Okay, so right now the trending is move to additive manufacturing, which is in order to form the shape. So the the additive manufacturing form of material, which is a filament type of wire, powder, even pellets. So into layer by layer. So the comparison between these two is they are significant of waste material. Okay, and of course this one also they are fast production. Okay, so 3D printing model can be created using a computer aided design, which is or via scanner. Also, we have a scanner. Uh, okay, and the manual modeling process of preparing a geometric 3D computer graphic is similar to plastic art, such as sculpture. Okay, for 3D scanning, it's a process of analyzing and collecting data of a real object. So each shape appear as a digital 3D dimension model. So for 3D scanning, basically you have a model. So you want to reverse engineering, you want to scan the object and interpret into the 3D dimension model. Okay, okay. So this one is the this one is basically the 3D printing operation lah. Okay, so for rapid prototyping slicing, so after we design, okay, we need to put the file into slicing. So slicing is the software that the printer, sorry, the slicing generate the G code. G code is the language that the printer able to read. Okay, so at slicing software, we can set any of setting such as layer height, the infill, the the color itself, the material, you can set on here. So basically, so this from the left figure, if we want to print this object, so the slicing will generate the movement of the printing. So layer, first layer, second layer, third layer until top. Okay. Okay, to form a to perform a printing, the machine read the design from 3D printing file. So the file we must save into STL. Okay, STL defined as stereolithography. Okay, so the file we put into the slicer, and after we slice, we put into the printer. Okay, so it's lay down successful layer of a liquid, powder, metal, or paper or sheet material to build a model from series of a cross section. So this model which correspond to virtual across section from CAD model. Okay, in and fuse to create a final shape. So the resolution of the layer thickness basically a 2D XY. Okay, and the highest the other axis is Z, which is the height. Okay. Okay, so the basically 3D dots are around 50 to 100 micron. Okay, DPI. Okay, after we finish, let's say after we finish printing, some of the project need to put on post processing. So basically, post processing is like make it soften the surface and make it shining, make it more beautiful. Okay. Okay, so basically there are few additive process. So basically extrusion deposition, or the other name is fused deposition modeling. Okay, granular material binding. Okay, lamination, photopolymerization, then mass image projection based of stereography. Okay, fused deposition modeling. Okay, basically 3D printing is famous on FDM, which is its model, prototype, and product and print. So FDM works on additive, which is the principle is laying down the material. We heat the material and put layer by layer. So in this FDM, it can be used on plastic or metal. Okay, even other material can also. Okay, so for FDM, the famous polymer that I use is ABS, PC polycarbonate, PLA polylactic acid, HDPE high density polyethylene, PC and mix of ABS. The last one PPSU. Okay, so the first one, this one next slide shows the configuration of the 3D model. So the first one is basically the nozzle that the filament going through the nozzle. So the nozzle will deposited on the bed. Okay, so the third one is controllable movement. So the third, let's say the nozzle. Okay, the nozzle will allow the filament to melt. So the bed, the third one, will move and will go downwards, and downwards, layer by layer, like a cake lapis. Okay, next one is granular material binding. Okay, so for granular, the granular is heat up and repeat process until the piece has built. So granular ni basically powder. Okay, this process used to infuse media to support or overhang that thin walls in the part being produced. So basically, they are powder that we heat up using a laser until it melts. So the specific point will heat up the powder into solid one. Also layer by layer one. So granular material building have three. So SLS, SLM, and EVM. So the difference is that SLS using a power source to sinter powder, okay, and bind together to create solid structure. For SLM, for using a high power laser, okay, to create a 3D product and fuse the metallic powder together. And for EBM, using so EBM basically using a metal part powder and using electron beam with high vacuum to heat up the metal powder. As for lamination, the sheet is lamination is like a layer of uh, layer of metal, layer of plastic. Okay, so the sheet will heat up into a specific temperature, and between them there are roller. Okay, so the roller will move, and the laser trace the desired dimension. So the laser will uh, move on the specific position of lamination. Okay, so it will cut the part that are not used. Okay, so it will become with movable, and the platform will move from left to the right. Okay, and the next fresh sheet will go uh, will go repeatedly. Okay, this is one is a lamination of material lah. So basically we have these two roller. Okay, so the movement will go to this one. So this one a new shade, and this one the laser. So it will specific the it will laser on the specific point. Okay, then after the layer is completed, so the sheet will move to the right side, and the new sheet will fill fill the fill the fill the fill the sheet. Okay, for polymerization, guys, can you see the slide? Hello,
Hello, doctor. Doctor, actually, your slide stop at slide number
stop
five.
it.
Slide number five.
Stop. Why stop? I
I thought
the
internet problem maybe.
this one can.
No,
Can you see?
not appear. Your slide is not appear.
Okay, right. Because
Try re-upload again.
uh, I thought it's okay already. Okay,
Okay.
okay. Can you
Okay,
see?
I can see your slide.
Okay, can I move the slide? Can you see? Okay.
Yes, yes.
So I will stay on this slide. I will go.
All right.
Will not go to the slideshow. Okay. So
Okay.
lamination. So basically, lamination is a type of sheet that 3D printing used to print. Okay, so this one is basically a configuration of lamination. So basically, there are two foil. Okay, from the left side to the right side. So when the new sheet come, okay, from the left side, we'll go to this one. So the laser will will heat up the specific point of the sheet, entire sheet. Okay, after it finish, it will go to the right side. Okay, the platform will move to the right side. So this one, this right right roller, so consists of waste. Okay, so the other one is photomerization. Okay, so photomerization is basically used in SLA to produce solid part of a liquid. Uh, so this type of 3D printing, use of liquid in to form of solid part. So basically, they are using light the DLP, light digital light processing, to wet the liquid polymer in exposed to light from the LP projector. So the build part then move down in a small increment that the liquid polymer is again exposed to the light. Okay, so in simple term, photomerization or SLA, there are certain container, okay, like this. Okay, this one full of resin. So the laser will specific heat up or wet solid the resin by specific layer, and the platform, after it finish, the platform will go downwards. Okay, and for mass image projection based stereography is that is the 3D digital model that is sliced by a set of horizontal plane. So each light is converted into two-dimensional mass. The mass then is projected into photocurable liquid resin surface. So light is projected into the resin to cure in the shape of layer. So this is example of the printer. So the left side is the wrap pulsar, okay, which is everything of uh, everything a component on the pulsar is need to assemble. Okay, so the middle one is marker board. Okay, the last one is other type of printer. The model is Airwolf 3D version 4. For the application that important in 3D printing, it can be used in rapid prototyping, mass customization, and mass production. So the domestic and hobbies, let's say if the new user want to buy 3D printing, it can be used for toy, clothing, bioprinting, and 3D printing service. So this one is other example of 3D product. So for biomedical, we can print of skull, okay, type of tissue, and basically even gun also can. And this one is a prototype of a architect building. And this one, when using a scanner, you can scan your face. And this one also is a type of modeling. Okay, for future, the future application of 3D printing may exclude creating open source scientific equipment. So science-based application can reconstruct fossil in pathology, replicating ancient price of architect, reconstructing bone and part in forensic pathology, reconstructing heavy damage evidence. Okay, so the even technology can also be even additive manufacturing can print a building, can print a building construction. So the effect of 3D printing, of course, it can be used for space exploration, making spare part on the fly, cheaper and more efficient space exploration. For social change, so conventional relationship between a home workplace might be exposed. It become easier to transmit design of new object into globe. So the challenges of 3D printing is that the there is no intellectual property right for 3D printing user. Nearly nearly can print anything using a 3D printing. Even you can print our gun, everything. It's matter of creativity. Even 3D printing can use for firearm also can. Okay, so okay. So the conclusion of this slide show is that 3D printing technology could revolutionize and reshape the world. So advance in 3D printing technology can signify change of improvement the way we manufacture product. So right, conventionally we use mold, plastic injection, vacuum. So right now we can transform into 3D printing, okay, in order to produce a good worldwide. If the last industry revolution brought us a mass production and event of economy of a scale, so it can reduce the cost itself and reduce the time and waste also. Okay, this is a type of reference that I use. Okay, so that's all from me. Okay, thank you.
Okay, thank you, Dr. Noden, for your good sharing. Okay, now I have a question from the floor, which is, what are the application that using 3D printing? Okay, so Dr. Noden,
Again,
okay,
I
what
what is?
okay, what are the application that using 3D printing?
Uh,
Okay,
okay,
that's the
so
question.
basically the application, yeah, the application that can be used for 3D printing, it's depending on the application itself. So of course, basically we start from the polymer, the plastic one, and we can advance to metal. They are the dimension. This challenges of the 3D printing is that the volume itself. Let's say for normal 3D printing, we have limited of dimension. Right now, there are research using only single arm to produce 3D printing, right? Using a robot like Coma or something like that. So for application, you mentioned just now, is that for plastic, I think basically everything Lego, everything built by plastic can be used, even chair, even automotive also the the dashboard on the automotive, the car itself can, and even seat, even the what cup holder can also can. That is your answer.
Okay, thank you for the clear explanation, Doctor. Okay, now we have come to the end part of the presentation. Thank you, Dr. Nordin, for addressing this interesting topic and for this sharing session. Hopefully, the presentation was beneficial for everyone. On behalf of Master University, we would like to thank you for joining us today. Thank you for your time and cooperation. So, goodbye and have a day ahead. Thank you.
Okay, thank you. Bye.